Hello everyone and welcome. My name is Khalil and in this video I will be discussing the research proposal prepared for the course GSOE9011. In the past few years, the world has been trying to shift to using clean energy such as wind. But why? According to the Clean Energy Council, it is by far the cheapest, and in 2017 alone, it has helped supply 6% of Australia's electricity. Now, the trends also show that the wind energy consumption is not slowing down and will rather increase exponentially in the future. Offshore wind turbines constitute one of the main sources of wind energy. These structures are usually supported by many types of foundations. Among these foundations, the gravity-based foundation, as the name implies, is a sizable foundation that is typically made of concrete and used at a depth between 20 to 50 meters where the soil conditions are considerably good. These foundations, however, employ a substantial amount of material and have a monumental impact on the environment and could also account for 24% of the total cost of the project. This is why they are far from meeting sustainability criteria. Now, society and environment could be thought of as the main pillars of the concept of sustainability. Sustainable engineering does not focus on the design alone, but goes further beyond to think about the whole system. It looks at the entire life cycle from cradle to grave. And here the question begs itself. Could we come up with a foundation which is a hybrid between an anchored draft and a waffle slab that can meet all these requirements but at the same time prove to be more sustainable? Well, this new hybrid foundation was modeled in the finite element software Plexus as a grid of interconnecting beams that are also known as the connector beams, serving as a transition between the deck unit that supports the tower and the touchdown beams that are directly in contact with the soil. The results show that under a uniform vertical load, the gravity-based foundation will settle uniformly as a rigid foundation, where the hybrid foundation will behave flexibly. Also, the bearing capacity of the gravity-based foundation is expected to be 870 kN per meter square compared to 740 kN per meter square in the case of the hybrid foundation. This preliminary analysis provides confidence in the success of this research, as it indicates that an 18% reduction in bearing capacity will contribute to 37% reduction in material. Now, to validate the previous results, a prototype of the hybrid foundation will be constructed and tested in a sandbox that will be flooded to mimic the offshore conditions. And the testing setup will be properly equipped to monitor the settlements and the stress changes in the soil. Our cost plan estimate shows that we will need a budget of 100 grand, inclusive of instrumentation, prototype construction, labor, and other resources in order to complete the experiment. We are extremely excited about the outcome of this research, as it will constitute a breakthrough in the engineering field, and it will give hope in a better future and a cleaner planet for the following generations. On behalf of myself and my team, I would like to thank you all for watching this video. I hope you enjoyed and have a good day.